Dave's already trailed a little bit of the goodness that comes with using our identity and access management service, and this next session is really to introduce you to more detail about identity and access management within AWS and talk to you about some good practices that you can use to make sure that your identities are structured in the right way and you can apply the policies and achieve the level of access that you need to achieve to your resources in a secure manner which complies with security standards that you or your organization might define, okay? So there's a couple of things we're going to cover. We're going to drop the demos because we're not going to have time for the demos, but we are going to talk about these best practices, these good practice guidelines, and then we're going to talk about trade-offs, kind of when you should use specific IAM features in contrast to other options that might be available to you. There's a lot of flexibility in this service, in this system, okay? And because there's a lot of flexibility, there are trade-offs and there are design decisions that you need to take when you're adopting and making use of IAM. And I'm going to talk about a few of these different design decisions and a few of these trade-offs during the course of this session. Just to introduce you to IAM, it enables you to control who can do what within your AWS account, okay? And the mechanism that it uses to do this is entities, users, containers, which are groups that you can group users together within, and then another entity type called IAM Roles, okay, which can really be considered as non-interactive user identities, okay, that you're going to use for systems-based access, or you're going to assume. We'll talk more about assuming roles later on in the session. That is essentially having a set of credentials, assuming a role from your account or another account, receiving a temporary set of credentials, and then when you work with those credentials, you will use the identity of the role that you have assumed rather than your own identity. Okay, and that's a very, very powerful feature that can be used to establish trust relationships and for a variety of other use cases, which we're going to talk about in more detail. And then lastly, you have permissions, which are essentially policies, access policies, that you attach to entities or you attach to containers, okay? So you can attach these policies at the user level, at the group level, or attach policies to IAM roles. And what happens under the covers here is that each entity can have associated with it a set of AWS API keys, okay? And when those API keys are used, the access key, which identifies you, and the secret key, which you use for signing requests made against the API, when you use a set of credentials which are validated through signature, or use an identity which is validated through signature, you have a certain set of permissions attached to your API request, okay? And that's essentially what happens in the background. And it doesn't matter whether you're using the AWS console, whether you're using one of our SDKs, or whether you're using the API natively, okay? Under the covers, the same entities are in play, and the same signing process is taking place. So when I use the AWS console with a user that I'm logged in as, an IAM user that I'm logged in as, requests that I make in the console are flowing through to the service APIs, okay? And they're being signed with the credentials of whatever user identity I'm currently logged into the console as, okay? So at the very lowest level, all that's happening is signed requests are flowing to our API endpoints, and then they're being evaluated for the policy that's attached to them, and they're either being permitted or denied. It doesn't matter which access mechanism you're using to control your AWS services, the same thing happens under the covers, okay? It's centralized, you have fine-grained control, and we'll have more discussion of what we mean by fine-grained control during this session. And then from a security perspective, we start with a denied by default policy. So new IAM users that you create or new entities that you create can do nothing, okay? And you have to actively attach policies to those entities in order to give them permissions to work with your service set. Now the exception to that is the IAM root user, which has special treatment, or the account root user to be more specific. It's an entity that isn't held in IAM, okay? And that user has full authority over your account, and we'll talk in much more detail about how you should treat that user in the course of this session. But in summary, very carefully, okay? Okay, so 10 plus IAM best practices, okay? So the first thing is, as I said, create individual users, okay? So do not, therefore, by implication, use the account root identity that is created when you create your account. The first thing you do when creating a new AWS account should be to create an administrative user in the account, attach an administrative policy to that user, assign a long randomly generated password to your AWS root user, assign MFA protected status to your root account user. Take the password, which you should print ideally, because she's probably going to forget it because it's going to be 16 characters and randomly generated, I hope. Take the MFA and secure them in 2 separate locations. Okay? Your root user credentials are then protected, and you can use the individual administrator account that you've created to perform all subsequent operations on your account. Okay? Reasons for this are many, but the root user's permissions cannot be restricted. They're always able to strip themselves of a password policy. They're always able to create resources in your account. They're able to do destructive things like delete resources or turn off auditing. They have full control and they can't be restricted. For that reason, they're a very dangerous entity, and really you shouldn't be using those credentials. Okay? Once you've done that, for each user, whether that's the first administrative user that you create or the 50th service role that you're creating in your account, grant least privileges. Okay? You can monitor permissions usage inside the console, as this slide says, and you can revoke permissions that haven't been used for some time, so you can actively manage a permission set. Of course, it's always easier to turn a set of permissions into something more permissive than it is to strip them. Okay, so start with this principle of least privilege. You'll be starting on a good foundation, and credentials or roles that you issue will have an appropriate set of permissions for whatever they're intended to be used for. And then we have these logical containers called groups. This is really echoing what Dave said about Linux, role-based access control, or other identity management systems which use this group-based container hierarchy. It's obviously simpler to manage permissions at the group level. You might have a group for admins, a group for developers, a group for no privilege, a group for your billing administrators, okay? And you can essentially assign user entities into these groups, and they will then inherit the permissions associated with the groups that they reside in. It's very simple then. If someone changes jobs or changes role, you can simply remove them from groups that they're leaving and add them to groups that they're joining, and they will then inherit the permissions associated with those logical entities. You can add additional controls, which we call conditions, to further restrict privileged operations in your account. And these conditions are very flexible in nature. This is where some of the fine-grained control element comes into play. So, for example, I could create an IAM user. I could give them a restricted set of permissions that enabled them to do upload only, so write only to a specific S3 bucket or prefix. Okay, so they've already got a very restricted permission set at that point. The credentials associated with that account can only perform that one operation. This is used quite frequently in data interchange. Where you might be my customer, I might be processing data for you, and you want to send me data, so I give you a set of credentials for AWS, which just allow you to deposit objects in a bucket or prefix that I specify. You can't read objects from that bucket, you can't even list them. But you can send me data, which I can then operate upon. Okay? I could further restrict that. I could say, right, we're only going to accept data, accept your credentials between the hours of 5 p.m. and 7 p.m. on a weekday, because I know that's the upload window that you're going to use. I could restrict it so that you could only access the API endpoint from a specific address block, a particular CIDR range. Okay? I could force you to use SSL for your connection, and there are many other conditions that I can apply as well. So these are additional restrictive permissions that you can feature within policies. Okay? And then lastly, we have an additional service called AWS CloudTrail, which we've mentioned in passing a couple of times already during the sessions, I think. CloudTrail is an auditing service that allows you to record AWS API calls and deposit these recordings as text files in a defined format, which will be deposited in an S3 bucket that you specify. Okay, and then you or your chosen third parties can analyze those deposited text files, provide visualization, alerting and other functionality to enable you to deal with events that you might want to detect or investigate. Okay, a good example of this is, where are my API calls coming from? You can see if you've got API activity against your AWS account that might be using your credentials coming from unusual locations in the world, which might indicate a credentials breach or that a set of credentials have been compromised, for example. You can also use it for event remediation. So I had a service that was working fine, now it's not. What are the most recent API calls that might have caused that service to enter a degraded or non-functional state? Again, CloudTrail can be extremely useful for that use case. Password policies. As long as you're not using root, you have full authority to set and enforce password policies for IAM users. So complexity, rotation period, preventing reuse of passwords that might have been used before, and a wide variety of other conditions as well. So configure a password policy for these users, which is in line with the password policy for your organization. Okay. Rotate credentials regularly. There are, in the case of IAM Roles, we'll return to and talk about in more detail later, there's automated credential rotation features built into IAM Roles. Okay, so for example, if you're using an IAM role with an EC2 instance to allow applications or software that you've got deployed on an EC2 instance to programmatically access AWS APIs, we automatically rotate the credentials associated with those roles periodically, but you should also do this. You can actually assign the capability to users to self-rotate their own credentials by using an IAM policy that defines that they have that permission set. Okay, so you can delegate this to users, or you can operate it automatically as part of your credentials management process. Multi-factor authentication. We support Gemalto tokens, which you can purchase from amazon.co.uk or amazon.com. We support soft tokens, so which are mostly deployed on phones. Okay, so you have something that looks like this. Authenticator, which you can store in that a lot of different tokens. There's actually a really cool one called 2STP, which I use, which has an Apple Watch app, so you can actually get your one-time password off your watch, if you've got one, and it'll synchronize across other iOS devices. That's a really good one, because can I tell you how many times I've had to contact AWS support because I wiped the user data partition on my Android phone, and that had all my MFA keys on it. I can tell you that support are very responsive if you do that, and they're normally calling you back certainly within an hour, often within 20 minutes if you have an issue like that. And you can report, I'm locked out of my account. Actually, on the console login screen, there's a little link there to do it. So if you do have an issue with your MFA, we'll authenticate you using contact details that we hold on file for you. This is one of the reasons that it's super important to keep your entity and contact details up to date on your AWS account. I had a customer contact me that was in a very unfortunate situation. They'd relocated from Singapore to the UK. They hadn't updated their mobile details, okay, so we couldn't phone them back on the specific number that was in their account. It was still a Singaporean mobile that they had in their account. They had to go through a paper-based identity verification process before we'd release access to their AWS account for them, because they lost their MFA. They lost the phone that had the MFA tokens on it. And in that scenario, I'm pretty sure you wouldn't want us giving your credentials out to somebody that was fraudulently trying to access them, right? So we have a strong control process around resetting account passwords and giving out account credentials that requires paper-based verification if you don't have your contact details up to date on our file. Okay, so that's very important to maintain that if you're going to use MFA. Of course, you should use it on your root user. You should use it actually on all interactive logins, in my view. They've put this up, so use it on all interactive logins. Obviously, you can't use this with things like SDK-based active access because they're non-interactive patterns. You know, you're going to have software calling your APIs. We have something else for that called STS, role assignment, where you can temporarily assign credentials from another identity, as I've talked about, and that's a solution that you should use for programmatic access to APIs to issue time-limited credentials. This is all we're talking about it now. Yeah, so using IAM roles to share access. This is one of the coolest features of AWS in my view. I can create a role in my account, okay, which might be maybe one of these data deposit roles. So rather than giving you a set of API keys so that you can write into my S3 bucket with that data that you want to give me, I can create a role inside my account which has that same permission, that same policy attached to it with all those same restrictive conditions. You can create an entity inside your account, another role or a user inside your account. You can give me the principal details, your account number, and the details of the entity that you've created, okay? I can then establish a trust relationship from within my account to the entity that you've created, saying I'm going to allow this particular entity to assume this role in my account, okay? And when you assume that role, you'll inherit the permissions associated with the policy that's attached to it, okay? So you can call an API requesting the role. That API will spit out a set of credentials that you can then use. You're using your credentials to access my account. I didn't have to share a secret or anything with you. It's still your identity, but you've got federated access to my account by virtue of this trust relationship, this policy that we've established between the two accounts. Very, very powerful feature, okay? Cross-account access, inter-account delegation, and identity federation all rely on IAM roles and the assumption of roles. Talked already about using IAM roles with EC2 instances. So this is where you want software that's running on EC2 instances to have access to AWS SDKs, sorry, AWS APIs, okay? And that can take the form of software that's written using one of our SDKs, or it can be our CLI. And our CLI is actually written on top of our Python SDK, if you didn't know that. So by virtue of that, as long as the Python SDK supports this role-based access model, then the CLI will automatically do so, okay? Automatic key rotation, as I already mentioned. And it's not just EC2 instances. I talk about it here in the context of EC2 instances, but actually these roles can be used for a lot of other AWS services. They can be used for other AWS services which fit this container model, which Dave was talking about. So Redshift, EMR, that's our Hadoop service. RDS, you might want to give those services the capability to work with other AWS endpoints. EMR and Redshift are very particular in this case because one of the things they do is they load data from S3. You heard of this concept of a data lake, where you have a data repository where you're storing large volumes of data. Then you might want to periodically apply compute resources to the data that you've got deposited in that lake so that you can load them into a structured data warehouse for analysis or process them using Hadoop or the Spark framework on our EMR service. It enables you to decouple your compute from the storage, right? So you don't need your warehouse around all month. You just need it for the 5 or 6 days where you want to run queries, or just need your Hadoop cluster for 40 minutes every day to do some large-scale data analysis for you and deposit the results somewhere. How does the EMR cluster or the Redshift cluster securely access the data inside S3? It uses a role. So you have a specific policy that you assign to it to enable it to access the data set that you want to work upon. Okay, it's the same deal. IAM roles enable that secure federated access from one AWS service to another. Make sense? I already said this, didn't I, at the top of the session. It's because it's the most important thing, okay? Reduce or remove the use of your root credentials. Always use IAM users. Protect your root credentials like you would protect a credit card. In fact, in a lot of cases, they're worth a lot more than a credit card because somebody that steals your credit card can't perform destructive operations that might put you out of business, okay? Somebody that steals your root account, if you've got mission critical applications and critical data assets residing on AWS, somebody has access to your root account, they can blow all that away, delete everything, and you'll have no recourse. Okay, so this is a super critical set of credentials. It needs to be protected in the most secure manner that you can muster. Okay, so that's there are 11 who started at 0. I like that. Okay, so yeah, those are 11 best practices for dealing with identities. So now we're going to talk about versus. You know, when should you use these options that are presented to you? And the first one is IAM users versus federated users. So when should you use these two different options, okay? And really this depends on where you want to manage your users. It's common for customers to have pre-established identity databases or identity directories before they start using AWS. And in those identity directories, they may already be managing administrator identities for on-premises infrastructure or for other IT infrastructure that they operate. So in that use case, it may not make sense to replicate those identities into AWS. You know, you're going to have another set of users that you've then got to manage, and you're going to probably have to make your processes a little bit more complex. So I've got a new administrator that's joined my team. I have this hybrid identity model where the identities are not integrated. So I then have to both create an identity for that user in AWS as well as create one in my other directory system. Wouldn't it be simpler and actually probably more secure to integrate that? So we've only got one process, therefore we're removing an opportunity to make errors when people move roles or leave the business, okay? And using federated users is a way that you can do that. It enables you to bring in pre-existing identities that might be in Active Directory or LDAP identity services, or actually other public identities that you might already have established out on the internet with other identity providers, and use those to assume roles within your AWS account, within your IAM construct, and those roles will have a certain set of permissions assigned to them. Okay. There are other important use cases as well. So, as I discussed, delegating access to my account to other users. My friend over here who wants to deposit data with me. So that's this federated users model where he's going to temporarily assume a role in my account. Okay. Mobile application access. We're going to return to that in a second because it's a very interesting use case. And then lastly, draining personally identifiable information from AWS. Don't know how much you know about law in the Russian Federation, but in Russia, there's an edict, piece of legislation that says, thou shalt not put PII in the cloud. Okay? Which kind of makes it hard because your username is PII. Okay? So you're logging into a system, the username that you use for that is personally identifiable. The way that a lot of our Russian customers tackle this is they don't have identities in AWS. They all use federated access. They give us anonymized tokens that identify authenticated users. When they give us the anonymized token, we give them back a set of access credentials. We don't know whether it's Boris, Yakov, or someone else that's accessing the system. All we know is that we've got an anonymized token which says they're authorized to do so. So they don't need to give us PII about who their administrators are. Okay. Now, mobile access is a very interesting one. Here's a use case for you. I got a photo sharing mobile app. Okay, I'm lucky. I've got 520 million users. How do I control what each of those users can access? I can't have 520 million S3 buckets. Well, I could ask. We probably wouldn't approve it. But there's no limit on S3 buckets anymore per account. But it's a big number, right? And you'd have to create them all programmatically, right? It'd be a lot of overhead. So how do you do that? Well, we have a service called Amazon Cognito. Amazon Cognito allows you to bring in identities. You can authenticate them yourselves and assign a token. You can bring in an identity from an identity provider like Twitter or Facebook or Google. Any OpenID Connect provider is supported. Or you can use another identity system, provide us with a SAML token, okay, and that will also allow you to assume a Cognito identity. Or we can create them for you automatically, randomly generating an identity for each unique user that visits the service endpoint. Okay? And then you can use these tokens in policies as expansion variables. So I can have an S3 bucket called My Photo App, which resides within my account and defines a namespace for S3 objects. And then I can have a $ Cognito ID, okay, and a /, and then I can have objects, or the rest of the prefix, okay? And each individual user out of my 520 million mobile users can have a policy assigned to them which says I can only access objects which have my unique identity present in the prefix. So you can coexist 520 million mobile users inside one S3 bucket. Each one only has access to their particular part of the namespace. Okay, and that's again done using federated identities, and these, we call them Cognito identity expansion tokens that you can embed within your policies. Okay, so it's very good for high scalability mobile applications with large numbers of users. And it's not just S3. I mean, you could do the same thing with our DynamoDB non-relational database, write records into our database, but have each user only able to access records associated with their individual identity. That's how fine-grained it is. It's individual documents inside a document store. Okay, you can apply controls at that level. It's pretty cool. Yeah. And it's actually a very hard problem to solve if you're trying to build that yourself. Never share credentials. So you should never give anybody a set of access and secret keys to your account. Always use this role assumption and federation model if you're able to do so. How does it work? So here are my two accounts. Okay, I create a role in my account. So it's my DynamoDB role, actually. So I'm going to allow another account to access my DynamoDB endpoint with a set of credentials from my account and work with data inside that account. Okay. I trust IAM users from the account over here. So this is the dev account. Okay. I'm saying that I'm going to allow. Actually, it's any IAM user in that account. It's quite permissive. Probably I wouldn't do that, actually. But it's quite permissive policy, but that's a policy that I'm going to apply. And the action that I'm going to permit is STS assume role. So I'm letting them call the API for the simple token service, security token service, and access temporary credentials via that API. Okay. And then I have my DynamoDB role that I describe. And here you can see that we're getting a little bit more restrictive. So you might have quite a permissive set of principles here. But what we're actually going to allow these principles to do is actually quite restricted. We're allowing 4 different API methods. Get item, it's quite self-explanatory. Batch get item, which allows you to retrieve a set of items, essentially, more than one item. So for optimization, where you might want to read a range of records or a range of documents out of the database, that's the API call that you would use for that. And that just allows us to do different optimization in the back end when we get that API call. You can describe table, so what are the attributes of the tables, and you can list the tables that are present in a particular user's account. Okay. You can't do anything else. You can't delete, update, or even write new records into the database. So this is quite a restrictive policy. So couple those two together, you've got a relatively constrained security stance there for this particular service. Okay. We assign permissions to one particular user to allow them to access this data, so to access this role rather. So the IAM user is Anders. Here we're getting, again, a little bit more restrictive. Okay. We allow this STS. So, and this happens at this side, okay? So in this account, we are narrowing the scope by attaching this policy to this particular principal, this particular entity in the assuming account, okay? Then Anders uses his own AWS access keys, the ones that are associated with his identity, his own access and secret key. He calls the STS API, and we issue back to him a set of temporary security credentials for the DynamoDB roles. So at this point, he has a new access and secret key that are provided to him, and he uses that new access and secret key to call the DynamoDB API endpoint in the appropriate region, and at this point is operating with this policy attached to him. Okay? But we don't give him any credentials. Okay? We've established this trust relationship through these policies, and that's what's enabling to work with our service endpoint, or work with the service endpoint and access entities that are within resources that are within our account rather than in his account. Okay? Make sense? Good. When should you use access keys or passwords? Okay? Very simple. Okay? It depends on how you're going to access AWS. So in the console, you're going to be using your account email address. Maybe on a specific sign-in page, if you're using an IAM user, you'll have a specific console URL that you access, which you have to share with users in your account. Okay? Your email address or your user ID if you're using an IAM user, your password, and then optionally your MFA. It's an interactive login. Okay? Access keys, well, they come into play for systems-based logins, we've already said, where it's software that's accessing our API endpoints directly rather than users that are being proxied essentially through our console experience. Okay? And there you're going to have your access and secret key, or even an IAM role automatically generates that access and secret key for you that's in play for access to the APIs. Okay? Either way, make sure you're rotating them regularly. Make sure that you're configuring a password policy, and you can additionally configure an IAM policy that allows users to rotate their own credentials as well. Okay? This is the policy that you need to attach to users if you want to give them the ability to rotate their own access and secret key, to rotate their own credentials. Okay? You can see these are methods on the IAM API that are going to be called by users that want to perform these actions. So IAM itself is managed via API calls, just like every other AWS service. Okay? Just describes the steps that you need to take to rotate the access key. He's not going to talk through this. If you want to access this, just download the slides. Okay. Inline policies and managed policies. Now, managed policies are actually relatively new. They've been around less than 2 years, for sure. Maybe even launched in the period that you've been here, so maybe less than 18 months. Okay, and they are, managed policies are policies that are managed on your behalf by AWS. And that serves a very useful purpose, which I'm going to come to in a second. But before we get there, what about inline policies? Okay, so this is where you need to enforce a one-to-one relationship between policy and principle. Okay, to really avoid putting the wrong policy on a principle, so having unrestricted access or less restrictive access than you might be aiming for. And it also is a mechanism to ensure that when you delete the principle, you're also deleting the policy. Okay, so what we're talking about here, for example, would be creating an IAM user, and when you do that in the IAM console, you can create a policy inline that you attach to that user. It's embedded alongside the details of the user inside the console and is tightly coupled to that specific user. You can still update the policy, okay? You can still strip the policy or attach another policy to the user in addition to the first one. but all of these inline policies are associated with that user entity or with that role entity. So when you delete the user entity or delete the role entity, all of those inline policies also vanish at that point. Okay, so it's good for coupling. Okay, it has a few challenges. The first thing is, what if we introduce, this is most obvious really, what if we introduce a new method on one of our service APIs? Okay, so, I mean, we've got maybe it's April Fool's Day and we have a new API method on S3 that allows you to reverse the contents of all your objects. Okay, so instead of ABCD, call this method all your objects become CBA. Kind of funny, but not particularly functional. Okay, assuming that you did want to use that feature, okay, I can't imagine why you would, but assuming that you did, how would you do it? Well, you'd have to go into all of your inline policies that featured the S3 scope, unless they had S3 star in them. So any restrictive S3 policies where you're only allowing access to a subset of the methods associated with that API. And you'd have to update them all. You'd have to add S3:reverse object as a accessible API method for those users where you wanted to add it. Okay, we can do that centrally on a managed policy. So we can update our managed policy, and all users that have that policy attached to them automatically inherit the changes that we've made to that managed policy. So it's centralized change management on the policies. It's versioning and rollback. It's delegation of permissions management. Okay, automatic updates for AWS managed policies, what I just talked about. And also these offer larger size. So we're essentially decoupling the policies away from the entities and managing them independently in a reusable fashion. Okay, there's a lot of benefits to that, but you then need to manage them independently from the entities. So it can be a drawback there. Okay. When should you use groups or managed policies? Well, it's not exclusive. Okay, so you can use groups and attach managed policies to groups. Obviously, groups, as I said at the top of the session, they're a logical container that allow you to group together entities, principally user entities. Okay, so you can logically group and manage users, and you can use managed policies in conjunction with those groups to apply the same centrally managed policy to a group of users. Okay, and again, use those managed policies in conjunction with roles as well. That's a pretty simple one to answer. Resource-specific policies based versus tag-based access control. Okay, we're getting into slightly more advanced topics here. So, resource-specific policies. This is things like S3 bucket policies would be an example of this. Okay, where you have a policy attached to an S3 bucket that defines a set of access permissions for that particular resource. Okay, so it's a resource-based policy, resource-specific policy. Tag-based access control, there's a smaller subset of services that this applies to actually. So tag-based access control applies to the services that are listed here: EC2, VPC, EBS, RDS, Simple Workflow Service, and the AWS Data Pipeline. And you should check the service documentation for other services that you're using or considering using to establish whether or not tag-based access control is supported for additional services, because we are extending it to other services. And what this allows you to do is to apply policies on the basis of resource metadata, essentially. Tags are resource metadata. So in the case of EC2, we can tag each of our EC2 instances with a set of key value pairs. Okay? The tag name and the value associated with that tag is commonly used for things like specifying which environment, which project, maybe which business unit, or with which cost center EC2 resources are associated. Okay, here you can see an example. The key name is project, and the tag value is blue. The value is blue. So then we can assign a policy, for example, attaching this to an IAM user or to a group to say that, right, all you guys on this side of the room are in this group called pre-production. Okay, you can all work with any EC2 resource and do anything to that resource which is tagged with blue. Okay, you guys, you're all in the production ops team. You're all in a group together, and to that group, we're going to attach a policy that can only work with resources tagged red. So you can stop and start EC2 instances as long as you tag them, and you can stop and start EC2 instances as long as you tag them, but neither of you can work with each other's resources. So it's separation of duties, essentially. Okay? You can use these tags for other things as well, like aggregated billing, reporting, and a variety of other users also. Okay? So that's tag-based access control. Oh, here we are. Yeah. So some builds saying the same thing. So here we have our 2 instances that are in that group. We've got some more that are in Project Green. They can't be accessed. Okay. Account separation. So as well as having the capability to create entities inside the IAM namespace in one specific AWS account, it's actually very common for customers to operate multiple accounts in addition to that. Okay, we have some customers, I don't know what the biggest number you've heard of. I've heard of tens of thousands of AWS accounts.
20,000 plus.
Yeah, so some users have a lot of accounts, okay? And bear in mind that until quite recently, we didn't have an API for automatic account creation, so probably these guys created those 20,000 accounts manually. These are the pros and cons, really. So single AWS account, it's simpler, you know, you don't have to manage user identities in a lot of different namespaces. You don't have to establish a lot of trust relationships, okay? And you might not need to isolate projects or otherwise separate your resources, okay? But with multiple accounts, you get some additional benefits. Those benefits come with an overhead, really, a management overhead of having to manage identities. So for example, rather than having that one set of root account credentials that you're going to have to secure, you're going to have one set of root account credentials per account that you create. So you're going to have to secure and treat all of those sets of credentials in the same way to prevent credential leakage, okay? The benefits, of course, are that you can isolate projects and teams. You can hand over full authority to IAM namespace management to different administrators, and they can't pollute or otherwise misconfigure each other's namespaces. And you can still use cross-account access with those trust relationships to give access to entities in other accounts to resources in the master account or in other trusted accounts that you may have. So you've got a lot of flexibility there. You can build something like mandatory access control that Dave's going to talk about later. And critically, you can still consolidate billing and take advantage of things like AWS volume-based discounting. Okay, so you can link these independent accounts to what we call a master or parent account, and then usage information and billing will essentially flow upwards into that master account. So if you've got 5 accounts, all of which have 100 terabytes of S3 usage, in aggregate, you'll take advantage of our half a petabyte breakpoint by having 500 terabytes of usage at the top level. Okay, so you don't lose the benefits of volume-based discounting by virtue of having lots of AWS accounts. You just got a small additional complexity overhead that you need to manage. Okay, and you can, as I said a second ago, establish this cross-account access using IAM roles. So in each one of your accounts, you can define whatever role structure you need and give those roles access to whatever resources you need with whatever conditions you wish to apply. And then, as we've said a second ago, you can have in your master, your IAM user in that master with this trust relationship established. Okay, so that will be using an identity managed within that master account, in that dev account in this case. Or you can switch that and have another IAM role inside your master account. You can trust roles, and then you can assume that role externally. Okay, so if you want to use federated identity in conjunction with inter-account trust relationships, you need to have a role which you're establishing the trust relationship with rather than a principal. Make sense? Or rather than a user. Okay, I think that is it. What did we cover? We covered 11 best practices for IAM, which is the anchor for the talk really. And then we talked about these 6 different selections, 6 different design decisions that you might want to make. I'll just close up by saying, I always say to users that want to become real experts in AWS, that one of the best places that you can spend your time developing knowledge about our services is to spend your time learning about IAM. It's used for everything, okay? So everything that you do on AWS will ultimately refer back to IAM, and that will govern what you can do and what you cannot do. So if you want to become an expert user and actually build a solid security foundation for things like principle of least privilege, mandatory access control, time-bound access, then IAM is the core of that, and you should really spend more time to learn about it. Okay? Thank you.